Welcome to the g.c.2.5 notes. These notes look at chord and central angle properties, and there are 3 theorems here that we'll go through. The first one and its converse are written. So if 2 chords are congruent, then their minor arcs are also congruent, and vice versa. If 2 minor arcs are congruent, then the chords that intersect those arcs are also going to be congruent. There is a nice proof here where you can look at the 2 triangles drawn, where the radii are drawn to the endpoints of the chord, and then that chord obviously then completes that triangle, and then similarly for the other chord, and the radii extend to its endpoints, and by side the triangles are congruent, and then once you establish that the angles are congruent in the triangle, the arcs they subtend or intersect are also going to be congruent. We are missing those angle symbols in that proof. And so to apply that, we look at the few examples that we have here. The first example, it shows that you have X, you have 33, 106, and we want to find the measure of arc CF, if you'll draw on that segment here. Looking at this, if we have the 2 chords are congruent, then the arcs that they intersect are going to be congruent. And so that means arc EF is going to be 106. And if you take away the 106 times 2, I suppose, and the 33, that'll leave us with the remaining part. And if you solve that, you get 115 degrees. If you look at the next example, we have 3 congruent chords. And so if these are all congruent chords, then the arcs that they intersect are also going to be congruent. And so if we take 108 away from 360, the total number of degrees in a circle, we get 252. And since those arcs are split evenly, you divide the 252 by 3, and we get the measure of arc CE or EF or DF is going to be 84 degrees. And if you take a look at the last example here, we are given a couple of different chords and a little bit of different information, and we want to figure out what is X. And so if you look at the arc, we have a 2 tick mark and a 1 tick mark make up this one arc I've indicated. And then you also have that the 2 tick mark and the 1 tick mark make up this arc. And so if the arcs are congruent, then the chords that intersect those arcs are also going to be congruent. And so if we have 10 and 2 make up one chord, then 10 and 2 make up the other, and X will equal 10 centimeters. If you look at the next theorem and its converse, it states that a diameter perpendicular to the chord also bisects the chord and vice versa. If a chord bisects another chord, then it must be a diameter or a radius. There is a nice proof here that shows it pretty concisely. If you look at the 2 triangles that are drawn, we have DA and DC are radii, and you have chord AC, and we have that the diameter is a right angle or forms a right angle. If you look at the last piece, DB, then we have HL actually shows the 2 triangles congruent, which then means corresponding parts are congruent. So that's why AB and BC are congruent, and then actually the arcs they subtend are also going to be congruent. And so looking at a few applications, we have here, it's all drawn for us really. The diameter is drawn through the chord at a right angle, so that means the parts of the chord are going to be congruent, and so that means that this small leg in the big right triangle is going to be 5. If you look at the parts here, we have a 5, 12, 13. The 12 really applies to not the entire diameter, but the part that I've indicated. And so if you look at adding the 1 for the diameter, which doesn't make sense really given the hypotenuse here, but if you stay with it, then we have 13 is going to be the diameter's measure. And then dividing that diameter of 13 by 2, we get 6.5 centimeters for the measure of X. If you look at the next one, we have that we want to solve for X, the hypotenuse on a small right triangle. We have 4 for one of the legs, and then because of the right angle and the radius drawn to the chord with a right angle, it bisects the chord. And so we know that this other leg is going to be 5. Pythagorean theorem, it says to round to 2 decimals, so no shame in using the Pythagorean theorem. We have 4 squared plus 5 squared is the hypotenuse squared. And if you solve this, we get x squared is 41. Taking the square root of both sides, x is about 6.4 centimeters. And to look at the last application, pretty brief comparatively. We are again given a radius drawn, and it forms a right angle with a chord, so it bisects the chord. We don't even really need to know that, though. We have a right triangle, 3, 4, 5. If this is the radius of the circle, and x is also a radius, then we know that 5 is going to be the radius, or x. Looking at the last theorem and its converse, we're told that if two chords are equidistant or an equal distance from the center of a circle, then they are congruent, and vice versa. If two chords are congruent, then they're the same distance from the center of a circle. There is a proof for both the theorem as it's written and its converse, but we're going to go ahead and go to the application straight away. Here we are given that the chords are the same distance from the center, given the segment drawn to the chord is congruent to the other. And so that means that the segment bisects the chord. The chords are congruent, just another piece of information since they are the same distance from the circle. And so we have 6.5 makes up that part of the chord, and then the entire chord is 13 centimeters. And since they're the same distance from the center of the circle, that means that the unknown segment or chord is going to be 13 as well. Here we have a square drawn. We have a lot of congruence tick marks. And so we have that the segment extending from A to the chord is going to form a right angle, and it's 4 centimeters. And then because of the congruence tick marks, we also have that that's 4. That's a 45, 45, 90. So 4 root 2, to be exact, is going to be the hypotenuse length. And then last but not least, we have a similar situation here. So given the segments drawn at a right angle to the chord, it bisects the chord. We are given the arc here is 90 degrees, and so we know that the angle here is 90 degrees. We know that the angle inside is going to be bisected because of the congruence tick marks on the sides opposite the angles, and so 45, 45, 90, it's all to say that the congruence tick marks are going to be 12, the hypotenuse divided by root 2, which means that x is going to be 12 centimeters as well.